Two Swiss geologists, Flavio Anselmetti and Stefano Fabri, specialists in lake tectonics, will produce a map of the bottom of the lake. Within weeks, 1/3 of the lake is mapped, and 2 subaquatic fault lines have been identified. The researchers will focus their work on the more southern of the 2 faults. Lying just over half a mile south of the city, the Iznik Fault is a segment of the larger Anatolian Fault system, which separates the Eurasian Plate from the Anatolian Plate. The line has a dangerous straightness to it, though.
A few years ago, it was discovered that on straight segments, there can be a very particular kind of earthquake, one that involves sudden slipping, which means that when the fault breaks, it slides apart at great speed.
Seismologists call this phenomenon super shear. On a straight fault, the wave of rupture that travels along it can advance much faster than the waves generated by the earthquake. The super shear phenomenon was first noticed following the Izmit earthquake of 1999. With a magnitude of 7.4, the rupture waves surged along the straight portion of the fault, worsening the destruction.
If a super shear earthquake were to occur on the fault segment that's just been discovered in Lake Iznik, it could lead to a massive dissolving of the soil and the whole shoreline being engulfed. That might explain how the Basilica of Nicaea was once completely drowned.
To test this hypothesis, researchers must learn more about the characteristics of the newly discovered fault segment, rupture length, past activity, and the magnitude of the earthquakes it has caused. Details about these past events could explain what happened to the basilica, as well as what might happen in the future.